When you think about the planet Jupiter, what comes to mind? Most likely, you picture a massive, swirling gas giant with bands of clouds and a storm known as the Great Red Spot. But what if I told you that everything you've learned about Jupiter so far is wrong? The truth is far stranger than what most of us have been taught. Jupiter is not a gas giant at all. It's a liquid metal planet. And this discovery has completely changed how we understand our solar system's largest planet. The misconception of Jupiter. For decades, we've been told that Jupiter is primarily made of gas. It's easy to believe given the thick cloud layers and violent storms we observe in pictures from telescopes like Hubble or spacecraft like Pioneer 11 and Voyager 1. However, what we see on the surface is just a thin skin of gas that hides an entirely different and far more complex interior beneath it. Jupiter's size alone is mind-boggling. This planet is so large that you could fit over 1,000 Earths inside it. To put it into perspective, if Earth were the size of a grape, Jupiter would be about the size of a basketball. But Jupiter is not only bigger, it's also denser. In fact, it is so heavy that it has more mass than all of the other planets in the solar system combined. With this massive size and gravitational pull, Jupiter is unlike anything we typically encounter on Earth. Theories of Jupiter's formation. How did Jupiter become so colossal? While we don't have a definitive answer, there are a few prevailing theories. One suggests that Jupiter started off as a massive chunk of rock and metal. As this chunk grew, its gravity attracted huge amounts of gas, which led to its massive size. This model implies that Jupiter has a dense, solid core made of rock and metal at its center. Another theory proposes that Jupiter may have started its life as a massive cloud of gas, similar to the way stars form. Over time, this cloud collapsed under its own gravity, leading to the formation of Jupiter as we know it today. If this is the case, Jupiter would not have a solid core, but would instead be composed of layers of gas, creating a layer cake structure. While this theory is fascinating, it's not the one most scientists hold. The Shoemaker-Levy 9 impact. In the mid-1990s, a pivotal event brought us closer to understanding the true nature of Jupiter. In July 1995, Jupiter was struck by a comet named Shoemaker-Levy 9. This collision was a rare event, occurring once every 6,000 years, but thanks to modern technology, we were able to witness it. The comet broke apart before hitting Jupiter, and the largest fragments were still about 2 kilometers in size. The impact generated an explosion that released the energy equivalent to 300 million atomic bombs, making it the biggest explosion ever captured on camera. What was even more surprising, however, was the aftermath. The impact created huge black holes in Jupiter's clouds and sent plumes of debris thousands of kilometers into the atmosphere. This provided us with the first real glimpse of what lies beneath Jupiter's iconic cloud cover. And to scientists that surprised, the data revealed something extraordinary. Water, a lot of it. This discovery raised more questions than answers, sparking a new era of research. If water could exist so far from the Sun, what else could we learn about Jupiter? Solving the mystery of Jupiter's core. In 2016, NASA's Juno spacecraft arrived at Jupiter with one specific goal: to investigate the planet's mysterious core. By studying the planet in greater detail, scientists hoped to answer the question that had long puzzled them. What is Jupiter really made of? Juno's findings have completely changed our understanding of the gas giant. Jupiter's outer layers are not just made of gas, they are a complex mixture of ammonia, water, and hydrogen, interacting in a way that forms violent storms. The most notable of these storms is the Great Red Spot, a centuries-old storm that is so massive it could swallow Earth. This storm reaches deep into the planet's atmosphere, where powerful jets of gas rise up and fuel the raging tempest. As we descend below the clouds, things get even stranger. The temperature and pressure increase as we move deeper into Jupiter's atmosphere. This heat isn't caused by the sun, but by Jupiter's immense gravity squeezing everything down. As we dive even deeper, the hydrogen gas begins to transition into a liquid state. And what we have here is something truly extraordinary. An ocean of liquid hydrogen? This ocean is the largest in the solar system, stretching about 20,000 kilometers deep. The strange liquid metal interior, but the real shock comes as we reach even deeper into Jupiter's core. At a depth of about 1,000 kilometers, hydrogen transforms into a strange state of matter known as metallic hydrogen. In this state, hydrogen is still liquid, but it behaves more like a metal. It can conduct electricity and, under extreme pressure, takes on a mercury-like consistency. This metallic hydrogen is what makes up the majority of Jupiter's interior. At depths of about 40,000 kilometers, it dominates the planet's core. And below this layer, there is a mysterious, fuzzy core of rock and metal, something far more complex than the solid rock core we once imagined. The boundary between the metallic hydrogen and solid rock is not sharply defined. Instead, the two are mixed together in a dense, swirling soup. What's in Jupiter's core? For years, scientists believed that Jupiter had a solid core about the size of Earth. This seemed logical given its mass and composition. However, the most recent research suggests that this core is much more ambiguous. It's like a molten blend of rock, metal, and liquid, with no clear-cut boundary between the layers. This fuzziness is what makes Jupiter so fascinating. It's not just a gas giant, but a planet with a unique and unexplored internal structure. Scientists believe that a massive collision in Jupiter's early history could explain the strange nature of its core. Perhaps a planet-sized object collided with Jupiter, disturbing its interior and creating this weird, mixed-up core. But even this theory remains speculative, as simulations have shown that while collisions could create this effect, the core would eventually settle into a more defined shape. For now, we don't have a clear explanation for the planet's bizarre inner workings. Jupiter, a mystery that's far from solved. What makes Jupiter so incredibly intriguing is that it remains a massive enigma. While we've made tremendous strides in understanding its composition and structure, there's still so much we don't know. From the possibility of ancient collisions that helped form its core to the question of how its extreme gravity influences its internal processes, Jupiter's secrets are far from fully understood. But that's what makes Jupiter such a remarkable planet. It's a giant mystery, and as we continue to probe deeper into its atmosphere and core, we will unlock new insights about the largest planet in our solar system. One thing is for sure, Jupiter is far more complex and fascinating than anyone ever imagined. Jupiter's complex nature. Jupiter is no longer just a gas giant in our minds. It is a liquid metal planet with oceans of liquid hydrogen and a mysterious, fuzzy core that defies our understanding of planetary science. As missions like Juno continue to study this enigmatic planet, we will continue to unlock new insights about Jupiter's formation and its unique internal structure. The more we learn about Jupiter, the more we realize how strange and complex our solar system truly is. Jupiter is a giant mystery in the sky, waiting to be solved. And there you have it, the mind-blowing truths about Jupiter that you've never been told before. If you enjoyed diving deep into the secrets of Jupiter with us, make sure to hit that like button and subscribe to the channel for more exciting discoveries from the universe. Don't forget to ring the bell so you never miss an update.